The definition of a microcomputer is that it is an embedded computer, a signal chip microcomputer. A microchip is a type of storage that contains microcode or firmware which is burned onto the chip. RAM versus ROM. RAM is a volatile storage, internal storage. Content is erased when the power is off. RAM is non-volatile, microchip storage. There are 3 levels to cache. Level 1 is on the CPU. Level 2 and Level 3 are not on the CPU, but Level 3 is larger and slower compared to Level 1 and 2, and it contains 512K to 2 megabytes. RISC is Reduced Instruction Set Computer. It has uniform length and uses a small set of instructions. It has simple hardware and decoding. Each command takes less clock cycles to execute. Single word instructions. CISC is Complex Instruction Set Computer. Multiple operations in a single line. Complex hardware. Hundreds of variable length instructions can execute at high speed. Primary memory is RAM, ROM, and cache. Secondary memory is permanent memory, hard drives, CDs, DVDs. For instruction time, you're gonna have to memorize these. For milliseconds, it is 10 to the power of 3. For microseconds, it is 10 to the power of 6. For nanoseconds, it is 10 to the power of 9. For picoseconds, it is 10 to the power of 12. Remember, milliseconds, which is 10 to the power of 3, is kilohertz, KHZ. Microseconds, which is 10 to the power of 6, is MHZ, megahertz, I think. It's 10 to the power of 6. Nanoseconds is gigahertz, GHZ, which is 10 to the power of 9, and THZ is the last one, which is 10 to the power of 12, and it's picoseconds. You're going to want to memorize the formula, which is 1 over F equals T. F is the frequency that the question will give you, so it'll be like 1 over 2.5 megahertz equals T, and then you just divide that and get the decimal. Once you get T, you're going to have to find instruction time, which is the number that they give you and times the decimal you got times the 10 to the power. So say it's 1.25 gigahertz. It's going to be, say they gave you 12 times 0.8, which is what you get by 1 divided by 1.25, times 10 to the power of negative 9, because remember, gigahertz is 9, negative 9 actually. And with that example, remember that to the power of 9 is gigahertz, which is also nanoseconds. So you're going to have the answer in nanoseconds. You're going to have the decimal like 9.6 nanoseconds. OS, which is operating system, manages all systems, it guides the CPU and utilization for all resources. PDS is a system software used by programmers that provides tools and utilizes it to develop both system and app softwares. A compiler is a type of system software which translates a high-level program statement into a machine-understandable code, such as C, C++, or Java. It produces programming written in assembly language. Interpreter is a type of system software that translates programming statements or commands into computer understandable code. It also produces a result of the code. This is mostly found in Python language. There are 2 modes, interactive mode and script mode, for interpreters, and also does line-by-line translation. There are 4 levels to programming. Level 1, which is machine language, and level 2, which is assembly language, are both low level. Machine language uses ones and zeros, octal, hexadecimal, and level 2 uses mnemonic code, symbolic code, MN, OM, INIC. Level 3 is high-level language, which is your C++, Pythons, and just the main languages. It uses necessary tokens and lines of words. This is also the first level, which is considered high level. And level 4 is application programming language, which gives you selection options from a menu. It is the most simple and user-friendly version of each level. For binary, you're going to have to start writing this down in your notes. Starting from right to left in the binary code, not the actual digits, it's going to be 1, 2, 4, 16, 32, 64, 128, and 256. Remember, the ones and zeros are going to be starting from right to left, but the actual digits I just listed are going to be from left to right. So from right to left, it's going to be 1. Say it ends with 1001. It's going to be 1 times 1 plus 0 times 2 plus 0 times 4 plus 1 times 8. Remember, we're going to be going from right to left in the binary code, not the actual digits. You're not going to want to start at 256 and then 128. You're going to want to start at 1 and 2. Just remember this. And octal is different. Octal doesn't have the 1 all the way to 256. It goes like this: 1, 8, 64. And then the rest is usually the same. But it also uses digits that are not just ones and zeros. Remember that. But other than that, the math is pretty much the same. You're going to be going from right to left in the binary code, or not the binary code, just the code. So remember, it's going to be 1, 8, 64. So say 247 was given as your code. It would be 7 times 1 plus 4 times 8 plus 2 times 64, because remember the 1, 8, 64, which comes with octal code. Now base 16 has new elements. It includes the alphabet to extend it beyond the normal 1 to 9. So it uses A as a placemaker for 10, B 11, C 12, and you know the rest. But this time it goes through the numbers 1, 16, 256. So say the code given is like 185. It's going to be like 5 times 1, remember I listed it already, plus 10 times, remember 10 is A, plus 10 times 16, which is the second digit I named, plus 1 times 256. So it would be 185, the code would be 5 times 1 plus 10 times 16 plus 1 times 256. That is base 16. Pseudocode is a semi-formal language, limited vocab that can be used to develop an algorithm. An algorithm is a sequence of instructions that clearly specifies how a task is done, a refinement of a plan of action. The problem analysis phase has 4 phases: input phase, formulation and assumption phase, which is basically just the formula phase, the constraint phase, and out phase. I am now going to list the sequence structures. The first one being simple sequence structure, executed in direct series with no branching. It simply continues a process. The second one is selection controlled structure. A path is selected based on testing conditions selected by the user or by the developer. Provides selection in the process. And the last one is loop controlled structure. The process is repeated until a condition is met. The control is transferred and allows to branch into different areas of the program. It repeats a process basically. Keywords are reserved words in the programming language. Most are lowercase, example int or diff. Identifiers are words designed by the programmer, which are basically just functions that the programmer assigned, which represents entities of the program. For example, total, process, or grade. The rules are that it cannot start with a digit, avoid special characters, and there are some length limitations depending on the language you use. Objects must be declared and defined. Declaration basically just means that you use an identifier to address the allocated location. Initialization means sets the contents of the allocated memory to a new value. The difference in string literals: lowercase x alone is a variable, single parentheses lowercase is a character, double parentheses with the x uppercase is a string, and x alone uppercase is a constant data object. Remember that most case variables are constant. Most uppercase variables are constant. Escape characters are things like \b, which means backspace, \t, which means tab, \n means new line, and f alone is used to format the value of long decimals. Say you have 56.397673 and you only want 2 decimal points. You would have to do print parentheses f and then quotations n double colon 0.2f. 2.2 meaning that you only want 2 decimal places, and then f just is the f character, and then you close quotation and then close parentheses. Brackets are used for valid expressions like pi, so you'd have to do parentheses f, quotation, and then bracket pi, close bracket, double colon, 0.3, because you want to end it in 3 decimals, and then f, which is the command we already talked about. Close close quotation, close parentheses. Two types of classes that can be used are primitive, which consists of logical, real, and numerical operators built in. Remember, that is built in. Reference are user defined, associated with the selection structure. Relational operators are things like greater than, less than or equal to, equal. Remember, the equal is double equals, and not equal is exclamation mark equal. Remember that. Logical operators are like and, or, not, nad, or nor. In controlled structure, it is required to transfer the control of the sequence from one area of the program to another. Controlled structure allows a group of statements to be constructed which has a single entry and single exit. Controlled structure module can be selection control or loop control structure. The definition of selection control is a type of structure where a programming path is selected based on testing conditions called selection control. Selection control can either be one-way selection or two-way selection. One-way selection just basically means one if, it just goes one way. Two-way allows else, so you can have multiple conditions to be set. The last selection style is called nested selection style, a type of multi-way selection control structure. The selection can be performed using if-else clauses. In this structure, more than 2 alternative programming paths are selected. The path is selected from among multiple alternatives, which is like elif. This is like basically just elif stuff. And count control loop structure is basically the for var in whatever. So you just have to ask the teacher for this because I don't really know what it is.